So yes, dear friends, so this is my lecture 5 in finite element method course or subject. So today I am going to tell you how to derive derivation of strain displacement matrix strain for 1D bar element. Okay, so today I am going to tell you how to derive the strain displacement matrix for 1D bar element. So first let me write down the sketch for this derivation. Okay, so this is x. So 1D bar element means it will be having only two nodes, node 1 and node 2. Okay, so if I assume this distance is x1, why it is x1? This is the node 1, and from this reference, so if I assume this distance as x1 and this as x2, this as x2, so what will be this distance? So one can easily tell this distance. If this is x2 and this is x1, so this distance will be x2 minus x1. That is nothing but length of this element, okay. So coming to the explanation, consider a 1D bar element, in global coordinate system. G dot C dot S means what? Global coordinate system, which is having two nodes. Okay, each node will be having 1 degree of freedom. Why it is 1 degree of freedom? Because at every node there will be only one displacement available. So that is the reason I am saying that every node will be having 1 degree of freedom. Okay, so now the strain is defined as how can I define the strain? So strain is equal to du by dx. So I am going to call this as equation number 1. Further, I will simplify this du by dx. I am going to multiply this with d zeta divided by d zeta. So nothing is happening to this equation, because if I cancel d zeta, I will be getting 1. So du by dx into 1. So nothing going to affect to this original equation. So now here I don't call this equation as 2. So here strain du by this d zeta I will be taking here, and d zeta by dx. So in this fashion I have written here. See here, we already know that the displacement field variable is the displacement field variable is, so the displacement field variable is given as what? U is equal to n1 u1 plus n2 u2, right? So I am going to call this as equation 3. See here friends, so in this equation 2, my intention is to find out first u equation, then I can do the differentiation of that u equation with respect to d zeta, zeta. So next upcoming I will be considering equation which is involving zeta, so then only I will get d zeta by dx. Understood? So that is the reason I have written this displacement field variable equation. So we know that n1 is half into we know that n1 is half into 1 minus zeta, and n2 is half into 1 plus zeta. So you may ask that why I have considered in terms of zeta only. Because here equation u I have to do the differentiation with respect to zeta. So that is the reason I have considered in terms of zeta. So this derivation I have already done in my previous lecture. This is the derivation of 1D bar element derivation of shape function for 1D bar element in natural coordinate system. I have not considered the shape functions in global coordinate system because reason is du by d zeta I want. So that is the reason I am considering the equation which is involving zeta. Okay, now I am going to substitute n1 and n2 in equation 3. So u is equal to what? Capital U or small u, both one and same. So n1 is half into 1 minus zeta into u1 plus n2 is half into 1 plus zeta into u2. Okay, so now I have to do the differentiation of equation 4. Now I have to do the differentiation of equation 4. So if I do the differentiation of equation 4, because I want du by d zeta, so du by d zeta is equal to, this is my u, small u or capital U, both one and same. So small du by d zeta is equal to, I have to do the differentiation with respect to what? Zeta. So if I do the differentiation with respect to zeta, so I will be getting what? Minus u1 by 2. Am I right? It will become, so because if I multiply half into u1, so constant I know I no need to differentiate. So minus half zeta u1, so zeta will be 1, so that is the reason minus u1 by 2 I am getting. Okay, fine. Plus, so coming to here I will be getting u2 by 2. Okay, so I am going to call this equation as 5. So next is, we already know that relationship between natural coordinate system and global coordinate system is given as what? Zeta is equal to 2 times of x minus x1 divided by x2 minus x1 minus 1. Okay, so I am going to call this equation as 6. See here friends, why I have considered zeta equation? Because as I have already told that, so in this strain equation, my aim is to, first I have considered u equation, then I have done du by d zeta, then I have got du by d zeta. Now I am considering zeta equation, then I will be doing zeta equation with respect to x differentiation, right? So okay, zeta in terms of x I have considered. This is also one small derivation. Hope I will upload in my next lecture. Okay, this is a small derivation. Okay, see here. Now differentiate equation 6 with respect to x. Here what I have done? Here I have done differentiation with respect to zeta. This equation u is there no 4. Equation 4 I have done differentiation with respect to zeta. Okay. See, differentiating equation 6 with respect to x. So what I will get? D zeta by dx is equal to, what I will be getting? See here, only with respect to x is there, not with respect to x1. So hence I will be getting what? So 2 divided by x2 minus x1 I will be getting. So further I can write x2 minus x1 can be given as what? x2 minus x1 can be given as length of the element, as I explained here. So that is the reason. So just I will be getting 2 divided by LE. So I am going to call this equation as 7. Okay. So now substituting equation what? Du by d zeta is 5th equation and d zeta by dx is 7th equation. Substituting equation 5 and 7 in equation what? Which equation? 2. Right? Equation 2. So fine, what is equation 2? Equation 2 is what? Equation 2 is strain is equal to du by d zeta into d zeta by dx. So what is du by d zeta? Du by d zeta I know that minus u1 by 2 plus u2 by 2 into what is d zeta by dx? 2 divided by Le. Am I right? See here what I will be doing next. So I will be taking half as common. So minus u1 plus u2 into 2 times of Le. So this 2 goes away, right? So now, so this is strain. So strain can be now expressed as, I have to express this equation in the form of matrix. So 1 by Le. So first I am writing 1 by Le outside. Then what I will be doing is, so minus u1 plus u2. So further what I will be doing here is, see here, so strain is equal to 1 by Le, so minus 1 plus 1 into u1 u2. So I have expressed this equation in the form of matrix. So okay, fine. So if I multiply this row and this column, I will be getting this original equation only. Thus strain is will be in the form of, now if I replace this entire term as b and this term as u, so where b is equal to 1 by Le minus 1 is called as strain displacement matrix. Fine? Understood? So thus completes this derivation. Thank you for watching.